Welcome to Matlab programming. So the topic today we are going to discuss is about the histogram of images, right? So this is the first slide, and I think you can see a camera. So a picture is being photographed. So on the left side of the screen you can see a singer singing a song, and that is being captured. And now you are going to see a still picture, and the right part of the screen shows the histogram, right? The histogram, so it is the representation of the intensity and the quality of the image, right? See, we can see the histogram, so it is being divided into two halves. So the left half is filled, but the right part of the histogram is not filled. So this shows that the light is not evenly distributed during the photo session. So every cameraman, or I think you would have been experiencing, so whenever a photographer shoots a picture, soon after he has finished shooting the picture, he will be viewing his camera. So he is trying to see the quality of the picture exposed. So this is the histogram, and this is the graph. So a good example to learn histogram is by using the digital camera. Right, this is the histogram, and it is the plot of x-axis, y-axis, and the x-axis consists of the number of pixels, and y-axis consists of the intensity of the pixel. Say for example, so if you take an image, so if it is an RGB image, so it's the pixels value will be ranging from 0 to 255. So 0 in turn it displays black, and 255 it displays its own color. So every RGB image is distributed between the pixel ranges from 0 to 255, right? So this is the graph, it is represented. Now this is the graph which is being expanded in the next slide. So it is a type of histogram. So histogram is a graph which acts as a graphical representation of the tonal distribution in a digital image, right? So a digital image, it has different pixels. Each pixel will have different values ranging from 0 to 255. If it is a black and white picture, it ranges only from 0 to 1. So either 0 or 1. So by a black and white image, what we call as binary image. So binary is a pixel, is an image having pixels either 0 or 1. So 0 is black and 1 is white. Right, so histogram, it plots the number of pixels for each tonal value. So by looking the histogram, you can able to judge the entire distribution at a glance. So the quality of the photo can be judged by the histogram of its image. Right, the horizontal axis of the graph represents the tonal variation, while vertical axis represents the number of pixels. So this is what we have seen here. So the x and y, we have x and y axis. The horizontal represents the pixel values, and the vertical axis represents the number of pixels. So say for example, if we take from 0 to 255, so for the pixel value 50, we have 3000 pixels. Say for example, for the 100, so for the pixel value 100, we have 2500 number of pixels in that range. So you can see the range. So the information contained in the graph is it's a representation of the pixel distribution, right? So image histograms can be analyzed for peaks or valleys. So you can see the peak. So the horizontal part we have the peak, and the vertical part we have the plateaus, right? So histogram is the tool which is used frequently by the beginner and improving photographers. So it's a tool. So it is a tool used by the photographers to enhance their images. So it's full of histogram is full of images. Sorry, it's full of information that you can use to make your photographs more interesting to the viewer. So it is a graph. So as already said, histogram is a graph. So image histogram is a distribution of light in an image. So most cameras are capable of displaying a histogram. So nowadays we all have a digital camera. So each digital camera, after an image is being photographed, you can see the histogram, and if the histogram is evenly distributed from 0 to 255, if the pixels are even in the sense the picture has to be covered. Say for example, if you see in this histogram, so it is fully covered. Say for in some other histogram, say for example, if you see the histogram in this camera, so the histogram has a good quality in the left hand part, but the right hand part, the right hand half has no pixel images. So this is not of good quality because the light, when you see the picture of that singer, right part near that mic, you can see the light, but behind her the portions of the picture is very dark, so that light is not being evenly split to evenly focused on that object. So we have to adjust. So with this, for this, histogram is used as a tool. So nowadays we have cameras, so we have Canon and other type of digital SLR camera. So I think you have now heard about SLR cameras where an online histogram is being displayed. So before even taking an image, you can see the histogram. If the histogram is evenly distributed, that image can be captured. So if the histogram is not evenly distributed, that it says that the light is not adequate enough to make clear photography. So you can adjust for lighting, or you can change the angle of focus, and you can take a photograph, take a clear photograph. So this is a brief introduction about histogram, and now we'll go to the Matlab software and try to execute a histogram. Alright, since this is a 2007 version and it takes some time to load, and now yeah, it has come. So I'm going to load a picture. Say for we are using the command imread. So a is a variable. I'm going to read an image. Say for example, pout.tif. So TIF is a format. So you have many formats for image, JPG, BMP. So in that sense, this is a TIFF format. So the TIFF format is used only to store compressed pictures. So where you can transfer pictures through internet. So it takes only minimum space in the internet. So I have read the image. See, we have the pixel value 78, 80. So this is I think this is a grayscale picture. So not an RGB. So if it is an RGB, you'll be having values ranging from 0 to 255. So since this is an RGB, since this is a grayscale, we have limited values. Right. So I have displayed an image. So I am now going to display the image. So by using the imShow command, imShow. So this is the image. So this is the image, and I think the darkness and contrast has to be improved so that the image is not clear. So it has to be improved. So we will use a tool. What we discussed before is the histogram. So now we will see the histogram of this image. Histogram images being displayed. imhist. So the command is imhist. So this is used to display the histogram of an image. So imhist of A. So we have the histogram. So this is the histogram, right? So this is the histogram of that image we are displayed before, right? So one second, I'll display the image also. You can use figure imShow of A, right? So we have both the picture and also its histogram. So this is the histogram of this image. So now there is a command in Matlab to enhance the picture. So histogram is a tool which is used to enhance the picture. So which is used to display the quality of the picture, and there is also a facility to improve the quality in the sense to improve the histogram. We are trying to use the improving this it is histeq. So this is the command histeq. So histogram equalization. So histeq. So histeq of that image of A. See, so this is the picture. So I'll try to show the previous one also, figure, right? So see, I have increased the intensity value. So this is the old picture and this is the enhanced picture. I think this contrast and brightness has been improved, and so that the image is being visible very clearly. So this is a image. So image histogram is a tool which can be used to enhance the quality of an image, right? So I will now try to show the histogram of the new image. So the command is figure imhist. So imhist is a function in Matlab which is used to show the quality of the image. See, this is the histogram of the original image, and now I'll change this to another image. So I'll change this to b equal to hist so histogram equalization. So that is the name of the function. So the new enhanced image is stored in the variable b, and I'm going to display the histogram of the enhanced image b, right? See, this is the enhanced histogram of the previous image. So this thing I have been written in a Matlab program. So this is the enhanced image. So if you need that old histogram of that variable which is stored in a, so this is the original histogram and this is the enhanced histogram. So this is the original histogram, so which we have stored in the variable a, and this is the histogram, improved histogram of that image which is stored in the variable b. So this is the original histogram and this is the improved histogram. So we are using the function histogram equalization. So this is the original picture and this is the enhanced picture. Yeah. So this is the Matlab program and this has to be executed. So if you have installed Matlab, so start trying this program. So I'll now show the program. I think you can take a screenshot or so. So this is the program. So this is the Matlab program, and I think I'll make the font size bigger, and so that you can take a screenshot on your mobile. Yeah. So this is the Matlab program. So you can take a screenshot. So it is of it is an image pout.tif is an image I have read in a variable I. So this is the histogram of that variable of that image I. So I have created a new variable j, and the histogram equalization is done on I and stored in j. So both are displayed. So original image I is displayed, original histogram is also displayed. So the enhanced histogram and the enhanced image is also displayed. So this is the out program. So and I'll try to run it in the Matlab. Yeah. So this is the Matlab output program. So this is the original picture and this is the enhanced picture, right? So you try to execute this in your Matlab installed version, and if you have any doubts, we'll discuss in the next class. Thank you.